looking for all integers such that this expression n squared plus 8n plus 55 is a square integer. Some people call that a perfect square. Now take a look at what happens here in the case n equals 1. This is just an observed thing. We get 1 squared plus 8 times 1 dot, not a decimal, dot 1 plus 55. Okay, and that sums up to 64, I believe. And of course, that is a square integer. That's equal to 8 squared. Now, so we found one solution just like that. Okay, so n equals 1 is a solution, right? But it says to find all n. Okay, so we'll proceed by setting the entire expression equal to a square integer. Do something called complete the square here, folks. And the idea behind this is you get a difference of 2 squares. Notice that what we did right here is took half of 8, which is 4, and squared it, and then added it and subtracted. In other words, this is 4 squared right here minus 4 squared again, right? Now the reason we do that, this clever, if you want to call it that, adding 0 in the middle of the equation, is that these 3 terms expand. N plus 4 quantity squared is these 3 terms. The minus 16 combines with 35 to give you 39, and then we get this difference of 2 squares on the very next line here, okay? And do observe this is the difference of 2 squares. So think of this as a squared, big A squared, minus big B squared. So you see this part right here would just be A plus B. I'll just write this out. A plus B times A minus B. Okay, so that's kind of a very nice result for us. You'll see A minus B like that. And of course, this whole thing, you can think of K as capital A, and you can think of N plus 4 as capital B here. Okay, now. So we got down to this circumstance here where we have 39 equals to a pair of, I guess, linear factors. Now, one thing to notice that's quite important is that, let's see if I can fit this in. This is 1 times 39 equals to 39 times 1. Okay, and this seems kind of silly to write it like this. And let me just write it over here. This is equal to 3 times 13 equals to 13 times 3. And you have to consider these 4 possibilities. And we can skip the negatives, it turns out. And you'll see why at the end, I guess. Okay, so folks, again, 39 can be written as 1 times 39 trivially, 39 times 1 in reverse, 3 times 13, and 30 times 3. We have to consider these things in reverse order because you'll notice these factors are different. So we can't just ignore the fact that the commutativity of multiplication. Okay, so the first case we consider is the 39 in the 1 case. Okay, which is this piece right here. Okay, 39 and 1. Now, if you sum up these 2 inequalities, the n plus 4 cancels with the n minus 4. 39 plus 1 is 40. You get k is equal to 20. And you can verify that n equals 15 is a solution. I won't go through the arithmetic with you, but n equals 15 is a solution. Okay? So, and then now y'all notice how I just do it in reverse here. Now we have 1 times 39. Okay? We still have k equals 20. When you sum it up, it doesn't make any difference what order it is, that the n plus 4s and the n minus 4s cancel, right? And so, anyway, you get 20 again, and you get n equals minus 23 when you substitute in. Okay? All right, now we're going to do the 3-13 case and the 13-3 case. Okay? And again, everything's very similar. Notice we got 1 by inspection. Look, we got it again. That happened with the 13-3 case. Okay, and finally we consider the we have 3 here and 13 here, okay? And you end up again with -9. So there's 4 solutions. The green values here are the 4 solutions. Now some of you are probably saying, what about the negatives? Well, I don't want to just make this thing so long that it's not, but it's, nothing changes. What will happen is if you consider -39 times -1, this would become -20. This would become -20 right here, but you would still get 15, and you guys can verify that. If you considered -1 and -39 here, you would get k is equal to -20, but you would still get -23, and so on all the way down. You guys, again, I would have to do double the work, but you get the same answers when you multiply the negative versions of these 4 cases. Okay, so effectively this was 4 cases. Technically it's 8 cases, but they kind of collapse on each other. So again, the only solutions are 15, -23, 1, and -9. She's smiling.